Good evening and welcome to the 11th edition of GraphQL Wrocław. It's nice to see so many people. And welcome to our new office. It's the first time that we are doing the event in Oławska office. Have you ever attended GraphQL Wrocław? Is someone here for the first time? Maybe. Yeah, a bunch of people. Nice to see you. Yeah, I know you guys. Yeah, so this is actually the 4th edition this year, last one. First one was remote in January, then we had one on the Tęczowa Street in our Tęczowa HQ. And next one was in Barbara, and now we are here, so I hope you will enjoy our office. It's not yet even open for our workers officially, but still, like, we wanted to try this out for the event. All right, so we have 3 talks today. Each will be around 20 minutes. After each talk, we will have a few minutes for Q&A. Some questions from you are welcomed. Don't be shy to ask. We have 2 speakers on site, and 1 will join us remotely. Yeah, we are streaming live as well. So I think we can start with our first talk. So please welcome Wojciech Trocki from Red Hat, who is principal developer, and he will tell us about applying GraphQL features to REST APIs. And we need to set up Wojciech's computer, right?
No, everything good. I hope you guys hear me. Oh yeah. Okay, so my name is Wojciech. And today I'm going to talk about building your own GraphQL. So imagine that you like to have GraphQL, but you just want to build your own specification for some reason. It's a fun talk, it's engaging, sometimes surprising. I hope you enjoy it. So first, a little bit about myself. I'm a team lead of the developer experience team at Red Hat Cloud. There we build APIs, not GraphQL ones. But I also work with the customers. I'm kind of working with the customers engagement team and doing lots of work about, API onboarding, GraphQL, etc. So first of all, before we jump into the talk, I'm going to tell you the typical developer story when I work with those corporate customers, right? So first we have some user that just basically see some issues with their mobile application they want to introduce. GraphQL, because the application has some invalid data, it's unreliable, and so on. And as usually, you have some security guy, someone at the company telling you, you cannot do GraphQL. It involves too much, it's just taking so much time. So what options you have, right? If you can do GraphQL, what else you could do? And there are a gazillion of options. Like over the last 2 years, I've been talking about different conferences about like generating the backend. You can do GraphQL client-side queries. So you can just do GraphQL only on the client and still do RESTful calls. You can do GraphQL proxy. You can use Hasura. Many, many different options, right? I tried them and we went to production with some of them. But then I started thinking, okay, you can use and force yourself to use GraphQL API, but can you sometimes actually use functionalities of the GraphQL, those best functionalities that you can get from GraphQL with your current system? So first, I started, reaching out to my contacts. I want to say that I contacted every big company in the planet. Actually, I just got a very little response from that. But from what I just got one response for this one basic question. What features of the GraphQL do you really need for your project to not fail? And there's this trick in this question, because it's like if you ask someone what you like in GraphQL, he will tell you like what's being repeated on a conference. But here I really want to know what really brings you to GraphQL. So what really helps you to adopt to GraphQL and be successful. And number one answer wasn't the thing that I actually got on the conferences. It was, everyone wanted to have SDK, want to have control, what kind of data and typings they have, and that should be generated. Like, I was very surprised because I was thinking like, everyone talking about documentation, overfetching. No, everyone wanted to have SDK for the language. So let's talk about those GraphQL functionalities and like things that typical persona doesn't realize how brilliant GraphQL is, right? So there is this simple thing. Okay, something. Oh yeah, so the slides were out of date. So first, in GraphQL, we have two objects. We have schema, which represents the backend. So this is what we implement on the backend. Schema just represents our data, and it's being later on matched by something called queries. And queries come from the user. So you have a user A has a different query for this specific object, and user B has different object. This is beauty of GraphQL, because you can have another app. You don't need to have separate backend for frontend. You can have one API that everyone calls for their needs and can generate their code. Okay. So, and sorry, my slides literally got out of. Yeah, okay, so then what you're getting is that you actually generating those different clients in TypeScript and Go. So this second user will have their Go client representing the query, and then the first user will have like TypeScript client representing the different query. So they got the very personalized SDKs for each. So how we can do that without GraphQL? We can use OpenAPI, right? And you probably, wow, Jesus, this old thing like this guy's talked about, right? It's like every time I bring the OpenAPI, it's like, okay, it was like we go back to 2012 or something. No, it's actually, I want to do the different take on OpenAPI today, because there is a more modern way, more GraphQL focused way that you can work with OpenAPI. So when you're generating clients with OpenAPI, by definition, at the beginning, you're being slammed by a number of issues. First of all, you're going to have very large models, because you don't have a choice. Literally in GraphQL, you're choosing the queries and you're getting what you want. Here, you're just basically getting entire SDK being in front of you. So your backend has 10 years of development. You're getting 10 years of development in the code in front of you. You have no guarantee that your API will work, because OpenAPI, it's being put as a basically, it's being written by people or generated from the backend, which also can be incorrect. So naming can be ugly. It's a different choice, right? And generators, most of the generators have some issues and bugs. So eventually, if we compare them, we can have that feeling like, okay, there's nothing to compare. GraphQL beats OpenAPI by tooling, but we can a little bit tweak it up. Even if we have some old standard that have been there for a while, we can always evaluate on it. So how we can apply this GraphQL features to OpenAPI? So there are a number of generators out there. The Microsoft done one. The most popular one, it's based on Swagger. The very version of this OpenAPI was called Swagger. So the project was called OpenAPI Generator. And let's just cover how this OpenAPI generator works. So you're starting with this OpenAPI file. So usually your team will need to either generate it from the backend, write it manually, and then this generator will have this model that's being driven from OpenAPI file. Then we have a templates, and later on we're getting this large TypeScript, JavaScript, every language you want, SDK. And basically when we think about this ecosystem in OpenAPI generator, if you have used that 6 years ago and use it today, you may think, oh, 6 years ago, maybe it's a little bit better. No, it's not. It's the same. So it's the tooling in a GraphQL evolves very fast. With OpenAPI, tooling is mature, is good, but it doesn't evolve that much. So for GraphQL, we usually use some tooling that gives us everything. For OpenAPIs, we need to apply this Unix approach. So we need to use the specific tools for the job and use those granular tools for specific tasks. So let's talk how we can extend OpenAPI to make it at least look like GraphQL. So first of all, we need to have ability to merge these OpenAPI files. Because imagine that you have multiple backends, right? And each of these backends is being exposed to a great gateway and interacting with that gateway. You really want to know what will be your overall API, not those just microservices on its own. It's very important to validate. Remember, OpenAPI itself can be written by person, so we need to have a way to check if you meet the standards, if the OpenAPI is valid. And the another problem when we building the code generator is that even small changes in the code generation can drive number of changes. So we need to have a way to minimize those changes only for things that we really want. So for that, we can use this pattern called filter and transform. So every change in the model, we filter and transform the same way that GraphQL does. So you have entire schema, but you don't get 7,000 queries. You actually need to write the queries yourself. So here is the same. We can actually do filtering and transforming of this OpenAPI object to the queries that we really want. And then lastly, if you want to have some extra capabilities, you can also customize the templates. So OpenAPI generator comes with the templates that are driving the languages, so they are used to generate those SDKs in a specific language. So that's there. So if we apply all of that, in theory, we should be able to actually avoid all those issues. All they're gone, and we have our own GraphQL without even using GraphQL. That's a theory. I want to show you the tools that you can use to try it out. So let's pick some tools to build this. So first, for filter and transform, on the very left, we have a GraphQL, and GraphQL comes with a schema. So remember this GraphQL schema, it's something that represents your data model and usually represents all the capabilities you have on the backend. And then you have a GraphQL document. This is what your individual teams working on UI and so on, and they're writing by hand because that's the data queries they have. And those data queries usually are being used, transformed by OpenAPI generator, Apollo generator, to actual TypeScript, TypeScript, Go, any language you use on a client to call this API. In OpenAPI, we don't have that abstraction. So we need to invent something. We need to bring this concept into OpenAPI file, because OpenAPI file itself represents entire state on the backend. So we need to have a subset of the OpenAPI just for our needs. And there are many different toolings out there. So if you like, I don't want to do self-promotion, but if you do like Open API filter, Open API transform, but I just want to show you the concept, right? So the concept is that you need to build additional metadata file, right? That contains like this get users, it's just operation that is being represented in your Open API file. And then you can pick the right fields from it. And what will be result, it just takes the Open API file from your backend and creates your own Open API file that you can use to generate the code. And then what you're getting, it's not the entire backend, it's only the methods and only the specification for specific things that you need. Merge, there's an existing project called Open API Merge. You can just run it in your CI/CD, run it in pipeline, merge multiple microservices into one Open API, and have your gateway. It can merge your security requirements, you can make sure endpoints and things like that. Validation. The problem with Open API is that it's basically generic. It was designed to describe every possible API on the planet. So you can even describe GraphQL API. If you're brave enough, GraphQL API can be described using Open API. And the problem is that there's some very weak spots of the Open API. I've been working with this for like the last 7 years. Every time I see all off or one off, I smell some issues. Because there's very hard, as a tooling engineer, building the support for those is very hard. Because there's multiple ways to reference the inheritance in the models. So if you have some inheritance on the backend, so something inherits from each other, it's very hard to reflect that then on the client side. The same way with the input types. GraphQL solved the problem because they have this new type in the schema called input type. In OpenAPI, you don't have that, so you need to basically have some validation to prevent users from not doing it. And I'm using another promotion. It's actually, you know, I'm not affiliated, but Spectral, it's actually doing, Spectral comes from Stoplight company. It's open source, you can use it. And basically what it does, it just gives you validation for your Open API. It can check if your Open API is valid, you have right examples, and you can even write your own rule sets. I use that daily to write some, you know, additional rules for the issues we see. It's very useful. It's very useful when we run it on a PR level. So if someone adds new functionality to the backend, we can run that as well. So we have all our tools in the right place. So we can merge, validate, filter, and transform. And you may ask, like, how about overfetching? So a little bit of overfetching, because like the biggest benefit of GraphQL is that you will you can query multiple endpoints by just sending one request to the server, right? So you can get entire graph by just one request, right? In that approach, you're still calling the individual REST services, so you can't really like minimize the overfetching problem. However, you will still be able to do some micro tweaks. For example, you can ask your backend engineer to introduce 2 headers. For example, if you want to select some fields, I do that successfully every time. Like we do header that selects user ID and name, and then on the backend they have this generic filter. So when we actually getting a result, we can filter results back to the user, so they only get user ID and name, and nothing else is being sent. It's still not, you know, giving us ability to batch the requests and things like that. And I don't know what happened, but I lost like 6 slides, so this is it. Thank you so much for watching.
Thanks for the presentation. Very nice stuff. Do we have any questions? Don't be shy. Yes, we have one, but we need to use the microphone because we are streaming, so.
Yes, seems like you have experience writing like clients for OpenAPI. What would be your suggestion, like if the API itself is not that big, I don't know, like 20, 30 resources, would it make sense to, like, if you want to have a quality client, would it make sense to write your own or like use this generation stuff and like auto-generated clients?
I will still always auto-generate it for a number of reasons. First of all, if you have ability to do the strong contract, it's all about API contract. So how you work with the backend engineers. So even if your API is small right now and you have, let's say, 20 objects, some process of negotiation, new changes from the product back to UI, back to backend, it's easier when you have a common platform to do it. I cannot imagine UI engineer goes to the backend and just tells on the database like, please change this and this. It's all about having the platform for negotiation. I can spoil a little bit Hasura, because if you use Hasura, you can avoid that because you will be able to use the UI thing to have the model. But if you don't use Hasura, you have no way to speak about this common thing. You need to have common language across different teams. For example, UI, backend, sometimes DevOps, a database admin, and OpenAPI and API itself gives you that. As well as, like SDK generation, you may feel like, okay, it will be faster, but evolution of it, if you can actually, if you imagine you have a bug and you need to put it into the backend, you can fix it on the backend within an hour and you can deploy it, but then your clients need to manually know what was changed, then reflect that into SDK, then add it to UI. It takes time. But now, how we solve that in Red Hat Cloud is that every time we have 5 minutes to deploy, right? Because there is huge CV, like error, that will affect our users. So what happens is that something goes to the backend, it's being tested and released, and we instantly get, once it's being released to QE, we instantly get SDK that being automatically injected in every client. That triggers automatic tests. So we don't even have a developers, right, that need to check it. We just basically see that things are working and we use the robots for it. So the many different benefits. If you like to write things from scratch and your API doesn't deal with JSON, you have files, some artificial file types, I think that will be received for disaster if you use OpenAPI generator, because it's mainly focused on JSON. But if you have just basic API, JSON-based API, I think you will be much better if you can automate it, do some CI/CD, as well have some level of validation as well. It's less like you can just deploy to production in 5 minutes.
Do we have any other questions?
Okay, in this approach, the client is consuming the OpenAPI that is generated from the GraphQL
No,
schema.
It could be, right? So you can basically have POC in GraphQL and then generate OpenAPI. But this approach actually, it takes the functionalities of the GraphQL and there's no GraphQL execution logic. So most of the time when I work with those enterprises, the challenge is not only to,
emulating the GraphQL using the OpenAPI in general.
So yeah, it's basically like taking some of the most important things from GraphQL and have them in OpenAPI, which is not anything new. It's basically all about reducing the OpenAPI specification to whatever size we want, whatever queries we want to execute, and then generating the SDKs.
Okay. Then basically this is like taking the best ideas from the GraphQL and implanting them on the OpenAPI standard, and then introduce the extra tooling to do these things.
Yes, and this is for special persona where someone tried to use GraphQL, but for some reason they cannot really deploy it. Like security guy in the company said that, sorry, you're not going to expose the API that you can call every possible element in a database, right? So those are the challenges we're dealing with those enterprise customers most of the time. And we still want them to use GraphQL, and we use that microservice approach. But then when we do it, we don't want to have some other teams that are not working on this backend that doesn't have that ability to feel that they are excluded. So we're trying to match all the functionalities on the platform, both GraphQL and OpenAPI, having the same capabilities. So you still can query what you want. You can still pick some resources and have at least similar experience. I can tell you straight away, if I give you the TypeScript code for your UI application, you will not be able to tell to me, like this is React hook generated from OpenAPI. You will never tell me is that you will not see the difference between OpenAPI and GraphQL. And that's the beauty of it, right? So engine that's being used under the hood is being completely abstracted by the capability. And capability is just being able to generate a client you really want to use. For example, I have situation when the JSON that's being returned for the user could be like 2 megabytes and you need 4 fields. And if we keep in this entire SDK, it will be disaster. It will be lots of code, the UI code will be large, but we can keep that to minimum and everyone's happy, right? Because the developers dealing with the models they really want and they can evolve them. It's also, evolution is very important because you can write these models by your hand and many people choose to do it. But when they do it, the problem is that someone changed something on the back end and then you need to figure it out what was changed. If with OpenAPI, you don't need to do that. You have that tooling that generates it for you, and like TypeScript and stuff.
There is still a problem of distribution where you have this OpenAPI generated. You still need to distribute it to the client.
Yeah, I love that question. I really love that question. I'm a big fanboy of the tool called Renovate, or if you guys know, GitHub has this thing called Dependabot. So what we do is that we have this CI/CD pipelines where every time something changed on OpenAPI, we have the GitHub event. We rebuild every possible SDK we have in 5 different languages in Red Hat Cloud. And then Dependabot deals with the rest of the stuff for ourselves. It just goes there, picks the like NPM modules, Go versions, Python modules, just injects them into clients. I don't even know our clients. Like, could be you, like using Red Hat Cloud, and you're getting automatic updates of our SDK, right? And then it runs the build on your side, checks if SDK is passing the build, and most of the time will pass. Sometimes you will fail, so then you need to have manual action. But if it will pass, it just auto-merges and you're up to date. It's magic.
So one question from me, and does it support somehow deprecation mechanism that GraphQL has, which is like very nice feature that I like, and it helps us a lot when releasing new versions, which we do like every 2 weeks or every month. There is a major release which breaks something, and with deprecation it really helps to keep clients working.
I love this question, but the problem with me is that if I start talking about it, it will be another talk. This is my thing, like with OpenAPI, deprecation by definition, it's not being supported at all in OpenAPI generator. So my team and many different community contributors have been building those custom templates that dealing with the deprecation strategies with OpenAPI. And there's some crazy ideas out there. For example, if you deprecate, maybe the new version of SDK should automatically remove that field so people will get their builds crashing, so they know that this is being removed. But trust me, we're not going to end up in we can talk about it, or I can prepare a new talk for next session.
Nice. It would be actually nice to hear.
It's a very good talk, right? It's a very good topic, and it's like there's so many different ways you can do that. Sadly, there is not a good way by default provided by, I don't know any generator that actually deals with this right now, but it's possible, and we do it.
Okay. I think we are running out of time, so thank you so much for the talk. Big applause to Wojciech for this presentation. And now we can continue to our second talk. So, Jesse, you can start installing your stuff. So our next speaker will be Jesse Martin from Hasura. He came to visit us from Berlin, if I'm correct. Sorry? Closer to Zurich. Okay. From what I remembered, like when we met 3 years ago, I think you mentioned you were living in Berlin or something, like in Germany in general. Yeah. So, yeah, we met 3 years ago at API Days in Paris. Jesse was hosting GraphQL. What was it called? APIs. Like basically GraphQL track at the API Days, yeah. And yeah, I was giving a talk back then, so it's nice to host Jesse this time in Wrocław. Yeah, so the talk will be about streaming subscriptions versus live queries. Are you ready, or do you need? All right, so please welcome Jesse Martin.
All right, so how y'all doing today? Everybody feeling like energized? Who was here for the workshop? Because it's kind of dark, I can't see. Who was here for the workshop? A few of you. So I really apologize that you have to listen to me talk for about 30 more minutes, but then seriously, like, I'm done with that. I don't have slides, primarily because of this tweet here, which you can see it was a couple days ago. So I set out to hand code my slides again, and I realized there's a reason why I stopped doing that a long time ago. So Ken Wheeler, if you ever see this, I am cursing your name, but I don't have any slides for you today. I do actually have a demo that I need everybody's help with, though. So you can all get out your phones, and we're going to do a little fun thing here. So I created a little game, or I guess it's more like interactive art, if you will. And we'll see if it actually works. So that's the other part of it. Can you actually scan the code? Does it work from there? I try to make it kind of big. So if you scan that, you're going to start to notice that you're going to be asked for your name. And then after you are asked for your name, you're going to be asked for your favorite shape. And then after you ask for your favorite shape, you're going to be asked for your favorite color. And when you start pressing on the colors, what you're going to see is we actually start to get some of these shapes popping up. And there's something that's a little bit hard to see. I don't know where I placed my, my laser pointer, so maybe this one's got a pointer on it. Let me have a look at that. Does that have a laser? It's like a red line on there. Yeah, we do. So you're going to see up here, if you can kind of tell, there's like a huge stack of things like building up now. It's like coming off the page now, so it's just going to roll off. And it's going to actually break the canvas here. I'm going to refresh the page. We're going to see something else happen here. I'm changing the cursor for where this bit of data here at the top is actually checking for new data. But this data is still representative of all the players we actually have. So every time you actually change the colors, it is giving me a real-time state of the updating data. But what's happening up here is I'm getting a stream of every delta change that's actually occurring. And so my talk today is actually about the two different kinds of GraphQL subscriptions that we support in Hasura, and just even in general about how we can actually kind of rethink this paradigm. I'm going to be refreshing constantly because I didn't actually handle the overflow. But what we have is we have two paradigms where, and they really do break down into an idea of a stateful subscription that we call live queries, and one that we call the streaming events. And so with streaming events, every database event that occurs compared to the cursor we give it, in my case an updated at timeline, versus a static query of just what is the current status, gives us a really interesting different ways of querying the data. If you think about looking at the different kinds of data we'd want to track, if I had one person counting is the light on or off, and one person counting how many times I've turned the light on or off, we have two very, very different bits of data that we actually want to track, and depending upon what you're wanting to be doing with that data has different value. Now, with inside of Hasura, I was told apparently I guess I'm the vendor talk, so I get to actually push Hasura a little bit more. I want to be careful because this is about subscriptions, but what's also interesting is we're actually able to do some cool stuff like changing permissions built in. So I've got a couple of different authorized tokens here. And I've got one here where now we're only going to actually see just the green shapes. So anytime somebody changes their shape to green, we'll see that. But I'm also only limited to the green color changes happening in my stream. So depending upon the kind of permissions that I want to apply to a specific JWT token, I can say, well, this person is subscribed to only this channel of updates, and this person is subscribed to only this channel of updates. And I could actually be able to have the ability to go back in time based on a cursor that I'm controlling as a user way back and actually see all of the updates that occur to a specific stream from the time that my cursor dictates. So that's what's actually happening when I refresh the page. It's getting the current timestamp, which resets the actual cursor of real-time data that I'd want to get. If I were to give this a cursor from 2 days ago, when I was madly testing this, we would get a flood of data coming in all at once. And so it's a really interesting way to actually work with your content. We can kind of look at how the code actually looks. Under the hood, it's actually not that fancy, right? So here's a typical GraphQL subscription. Let me see if I can boost the font size on that a little bit. And I'm going to hide that messy sidebar there. So that's like a regular subscription that most people who know GraphQL actually have worked with. So let's go ahead and actually go for my message stream here. So now we're going to do some fancy coding here. Sorry about that. So let's look at the message stream here. So the only thing that I really had to do was just put _stream on the end. And then I had to change a few things, right? So I now have like a batch size. I have to determine what size of batches I want to actually stream that data in with. I have something like the cursor, which is going to be what I'm actually trying to track. In this case, it's going to be my updated at value on my database. But beyond that, that's all I need to actually implement a really complex feature that actually has a lot of benefits for us. So you may have heard there's going to be some new changes to the GraphQL spec, things like @stream, which is the thing we hear the most that it's being compared to. The biggest difference is that @stream is actually server dependent, right? So the server is going to be sending batches of data to your client based on its own choice of when that data becomes available. With this one, I as the client get to choose when that data actually becomes available to me. So I could say, as a client, I want to configure everything from when I was last online. Maybe I'm off in the mountains or something and I want to get the message queue streamed in after I go back on connectivity. So as a client, I get to control the actual ownership of the stream. And that's something that WebSockets give us that the @stream won't be able to handle very well. So it's a pretty simplistic demo. We can go back to see how badly the UI is blown up here. And I wanted to kind of show, if I've got a few more minutes here, just a little bit how we can kind of compound on here. So I only have a couple of different tokens here to pass in. I've got this generic one. I have this only green one. And then I wanted to see if we could actually modify the permissions for a only circles, because shapes and colors are about as complex as my brain can think tonight. So we're going to go over to our system. I do have slides. If there's some technical questions, we could go over it, but they're Google Slides, and they're very, very boring, so we'll try to avoid them if possible. Here we have the actual data. I'm going to go ahead and grab a token. So I've done the thing that you're not supposed to do, and I've hard-coded my tokens here inside of my code. So I'm going to go ahead and grab a couple of my tokens here to have a look at. And that is going to be inside of my header. And that's inside of my role switcher here. All right, so dynamic role switcher. I'm going to have a quick look at that. And so my only circles token, we're going to grab this here. We're going to bring this inside of Hasura and have a look at what it actually looks like. So if you haven't seen the Hasura interface, here you go. I'm going to go ahead and pass in the authorization here. This is a lot harder with one hand, actually. I should have taken you up on the mic stand. I'm going to go ahead and actually decode this JWT here. So we'll see if you can tell there that we've basically got a role of shape, and we have another value coming in off the JWT called circle. So it's like, this is the shape that I want. So what we want to do is actually put some permission controls for this role that's going to limit my selection based only on if I actually am fetching for circles. So let's go ahead and have a look at how we would do that. I'm going to go ahead and go to my tables here. This is just a Postgres database. Actually, this is using Neon, which is the new integration we launched today. So please promote us on Product Hunt. We would appreciate it. But I'm going to go ahead and go to the Canvas messages here. And this is just a channel subscription kind of concept. I'm going to go ahead and go to permissions. And so I have a role here for not a shape yet, so we'll make a new role. And we'll say whenever that role shape comes in, we're going to put a select permission on here. And we're going to say with a custom check, and that's going to be when the shape of that message actually matches to, and it was going to be the Hasura shape. So it's going to be if the shape happens to equal circle, then we'll be able to limit that down to just, wow, I can't really type from this distance. Okay. Yeah, I think that's how we had that. And we'll say, you know what, they can go ahead and select all the columns. That's fine. And I'll need to do some aggregates allowed because I have some counting things going on. And I think I need to give that role permission to my canvas, if I recall right. So we'll go ahead and go to permissions. And I'll say that my shape person needs to be able to select from here. So we'll say, without any checks in this case, we'll go ahead and toggle all. Because we play willy-nilly with permissions when we're in DevRel. And then we're going to go with the user table here to give that one last little bit. Make sure I'm not missing any data. Because GraphQL is very good at crashing on you if you actually don't give it the permissions that it needs. I'm going to go ahead and go to the shape role again, and we're going to select that. And so, theoretically, if this worked, we're going to go ahead and say, without any checks, toggle all, and we're going to go ahead and hit save permissions. And we'll head back to that demo here and see. So now if I refresh the page here one more time, so we'll look at we're on the only green one. We'll go back to generic so we can kind of see what it looks like to fetch all the data again. And now we're going to need some more activity here. If we go to only circles, we've got the shapes, and now we should also see only the people that have shape objects. When you update your colors, then we'll only actually see your events streaming across the top. If anybody who's a shape circle wants to update, if it worked. There we go, there's a circle. Because there's some circles, they're already coming in. All right, so, and you can see how that's just a really powerful way to work, is that this actually allows you to have this idea of messages and channels and being able to work with really fine-grained permissions that otherwise would be relatively complex to set up. If there's some technical questions about it, I'm happy to answer those. Some of the things we had to address were issues like back pressure. So one of the ways that we solve that at Hasura is we actually, if you're not familiar with how Hasura works under the hood, what we do is we take the GraphQL query, we transform it to GraphQL to SQL, and then we execute that against your database. And when it comes to the idea of multiple subscriptions, we stress tested this up to over 1 million active connections. And that was a really big bill. But when you stress test it to that level, you actually have a lot of independent cursors being tracked on the database to say, okay, when was the last time this client needs to be getting its data? And so what we were able to do is we actually batch process in the same part where we do the authentication checking. We say, okay, all of these clients are actually asking for the same cursor or the same time window, and we're able to actually batch process multiple fetches for multiple clients, and then stream those back out to the people asking for them. Instead of having individual queries against the database, we're able to actually sort of, I guess hyperplex might be the right description. But it's a really interesting use case, and we did stress it to over 1 million active connections. It is live now. It's in the open source version as well as on the cloud version, so you can absolutely go and test it out. But this is kind of what I wanted to show you, was this functionality between streaming versus stateful. All this data up here is stateful, all this data down here is streaming. And you can see that the real benefit there is that instead of having to send potentially thousands and thousands of records every half second that a WebSocket is pinging the server, I can actually just send the one bit of data that's changed over and over, as opposed to having to send a massive payload down the server. So yeah, that's the demo. Are there any questions?
Do we have any questions? What I really liked is that you were able to express a bit of business logic just using the headers and the configuration in the panel. Was the permission thing from Postgres, or this is part of Hasura engine basically? That's
a Hasura thing. So we have an RBAC system where we can get really fine-grained on the permissions, especially with GraphQL. You can actually use relationship-based permissions. So you could say the permission of these two, to access this row is based on this other table that has a relationship to that table. And that's the kind of expressiveness that GraphQL gives us that's really great for, especially with permissions, yeah.
Yeah, it would be great to see this example that we talked about before your presentation, actually, because we are chatting about use case for Hasura, that if you have a e-commerce site, as we like built at Sailor, for example, you could use that to build this feature where you can show like how many people are now viewing, you know, this product, or like some live updates to the product page. So actually, I would like to try this out. Is this like demo open and like?
It will be open once I remove those tokens out of the code base. Actually, it is open. It's on my GitHub repo. It's rather messy, but I think it's the Wroclaw event flow, so it's a free database. If you break it, then I'm not too sad.
Yeah, we have one question.
So yeah, another question related to what is on the part of Hasura and what is handled by SQL. So the event stream, the event history, this history of changes which were done on the DB, it's stored on the Hasura side. Yeah, of course, there's no way to get this from PostgreSQL, like get the history of the inserts, or how do you do it? Or?
So it is on the Postgres database, but we have to use some special code on the Hasura side to actually interpret what was the change diff based on the cursor. Mm-hmm. So the same thing for subscriptions. We're using built-in Postgres functionality to be able to look at the change log. But when it comes to the streaming bits, we actually have to do some diffing on the server to say, okay, this is the latest delta that goes down.
All right, thanks.
Thanks for the questions. Any other? If not, then thank you, Jesse, for the presentation. Please, big applause for Jesse. So now we will have a 5 minutes break because next talk will be remote, so we need to set this up. So make sure to grab a drink or a beer or some snacks in our kitchen, and we will see you in 5 minutes here. Us remotely. Can we have Rob on screen? Hello, Rob. Can you hear us?
Yeah, I can hear you.
Great, we can hear you as well. So our next guest is Rob Richard, who is a front-end developer at First Dips. And he will tell us about defer and stream directives, which is kind of related to what just Jesse was talking about live queries. So please welcome Rob Richard. You can share your presentation now. Yeah, we can see it.
All right, great. Yeah, thanks for having me. My name is Rob, and I've been working with the GraphQL working group on the defer and stream directives, which I'm going to talk a little bit about today. Yeah, so about me, I work for First Dibs. It's an online marketplace for high-end furniture, fashion, and art. And you should all check it out. Our stack is based on GraphQL, React, and Relay. And we've been using GraphQL in production since about 2015. So before we go into defer and stream, I want to talk about the problem that we're trying to solve. So GraphQL is great at taking all of your application's data requirements and making a single request to the server. And the GraphQL homepage advertises this. It's a major feature. You can get many resources in a single request. But this could be a bit of a drawback because it means right now that you don't get any results until your entire query is ready. So even if most of your query's data is really fast, just one piece of slow data will slow down your entire request. So defer and stream are meant to directly address this drawback. It allows you to deprioritize the parts that may be less important in order to lower latency of the most important part. Yeah, so defer and stream, they're new directives for GraphQL. And like I said, the goal is to lower latency of the most important data in your query. So you can use the defer and stream directives to tell the server which data on the query can be deferred. And the result of that is that the non-deferred data can be returned sooner and can be rendered by the client while the rest of the data is still loading. So use the defer directive on a GraphQL fragment, or you could use the stream directive to defer list items on a list field. Yeah, here's a quick example of what a page that uses defer and stream looks like. You can see on the right side that the deferred parts of the data are loaded. The non-deferred parts are loaded when the deferred parts are loaded whenever they're ready. And on the left side, you don't see any data until the entire query has loaded. I'm going to play it a few more times. So by adding defer stream, you're going to get multiple responses from one request streamed to the client instead of one single big response. And the client can render these results from the initial response immediately while the rest of the data is still loading. Another way you could do this is to just use multiple queries, but that has downsides. It's additional coordination work. It's more code you have to write on the client to keep track of these multiple requests. There's overhead when you're doing multiple round trips. And if your downstream queries require input from your upstream queries, that will even further slow things down. You might also be wondering how this compares to GraphQL subscriptions. And it's because subscriptions are another way of delivering multiple results from GraphQL servers. But subscriptions are intended to allow servers to deliver real-time events to clients, while defer and stream are intended to lower latency of essential data. And the idea isn't to make your query take any longer, but you just get the most important results sooner. And with defer and stream, we can send the responses over a short-lived HTTP connection, a streaming chunked HTTP connection, and we don't need to use WebSockets or other stateful connections. And that means that it's simpler infrastructure to get things running. So a quick history of defer and stream. Lee first talked about it in 2016 in a conference talk that was about a few different ideas for new features for GraphQL, and defer and stream were some of those. And when I saw that talk, it immediately got me interested in this. I saw how it could solve a lot of challenges we were facing at First Dibs, but there wasn't much movement on that idea for a while. We heard that Facebook was experimenting with it internally, but there wasn't any way to use it outside of Facebook. And a few years later, we started seeing support for defer and stream being added to Relay, but there still wasn't any open source servers that were compatible with it. So it wasn't something that you could just start using in your code base. So some of my colleagues and I started working on adding support into GraphQL.js so we could start using it. And we really want everyone to be able to use it. So I've been working with the GraphQL working group to get this feature to become an official part of the GraphQL spec. And it's evolved quite a bit over time in the years that we've been working on this. Right now, it's in stage 2 of the 3-stage GraphQL RFC process. The code is merged into GraphQL behind an experimental flag, and a lot of servers and clients have been implementing support now. So to get into some more of the details, starting with defer, the defer directive, you can use it on inline fragments and fragment spreads, and it takes 2 arguments, an if argument and a label argument. The if argument works similar to the same if argument that are on the skip and include directives. If it's true, the fragment will be deferred, but you could also pass false, and that'll tell the server to ignore the directive and not defer the data. So you can control if something gets deferred or not with query variables. And then the label argument is a string that you can pass in, and that string gets mirrored back in the response. So if you have multiple defers in your query, your client can use the label to know which response corresponds to which defer. Yeah, so here's an example of a query using defer. And we're loading the name and home world of our hero. And let's say that for some reason the home world is an expensive operation. By deferring the home world fragment, we can get our hero's name while the home world is still loading. You see that there's two responses there. The first one has the name, and that one will come as soon as that's ready. And then whenever the home world data is ready, that second response comes in. Yeah, so to look more closely at the responses, there's the new incremental property. That's a new top-level field on GraphQL responses. And all data that's associated with defer stream is going to be returned inside of that array. And you could see the deferred data is included in the incremental array in the second response. Then there's the hasNext property, which is going to be present and true when there are more payloads that'll be sent. So, and then the last response will always have hasNext false. And we're not adding hasNext to single response operations because we want to preserve backwards compatibility with GraphQL servers that don't have support for defer and stream. Then inside the incremental array, there's these payloads for defer. That has the label property, and that's the same string that was passed to the label argument on the directive. And like I said, if your query has multiple defers in it, you can use that label to identify the payloads. Then there's the path property that will be a list of keys from the root of the response to the insertion point of the deferred data. And the data field is the actual data that was deferred. And so if there's any errors encountered while executing the deferred data, they'll also be present inside that payload inside of the incremental array. Then for the stream directive, this is a directive that you can use on list fields, and it allows us to get some items from the list while the rest might still be loading. Just like defer, it also has an if argument and a label argument, and those work the same way here as they do there. And there's also the initial count argument. And this is the number of list items that the server should return as part of the initial payload. And all items that come after that index will be sent in later payloads. So here's an example of a streamed list. We're asking for the list of films, expecting the first one to be returned as part of the initial payload, since we specified an initial count of 1, and the remainder of them to be streamed. Then on the right, we see that the first film is returned immediately in the first response. We then get 2 more responses with each additional film. So you can imagine using this in a newsfeed style UI, where you can render the first few items above the fold as soon as they're ready, and while the rest of the items are still loading in the background, they could be rendered whenever they're ready without blocking the most important data at the top of the list. So to look more closely at the responses here, we have that same incremental field again. That's your wrapper to hold on to the stream payloads. And again, we have the hasNext field to let clients know if they should expect more data. And inside the incremental array, you have the same label and path fields that were used for defer. And the results of the streamed list field are going to be inside the field called items. And again, if there are any errors encountered while we were executing the stream list item, they would also be inside that payload. And we also support batching. So you wouldn't want to overwhelm clients that try to re-render UI on each payload when many responses are sent in rapid succession. So one way to avoid that on a query with stream, we could return multiple items from the streamed list at the same time. This allows more efficient delivery of large lists. And here the path points to the index at which the range of items should be inserted. And you could also batch entire payload objects. So the GraphQL server could return multiple defer and stream payloads inside that incremental array field. This has the benefit of being able to return batches of both deferred data and stream data from any field instead of just stream data from a single field. And the initial response could even have some of the deferred or stream data. So going to spend a few minutes diving into the GraphQL execution algorithm. If you work on GraphQL servers, or you want to really get into how GraphQL works, this will give you a good understanding of how defer and stream works behind the scenes. So going to start off talking about how GraphQL execution is currently defined by the spec. Then I'll move on to what changes when we introduce defer and stream. So the spec starts off with a function called execute selection set. And a selection set is a group of fields, inline fragments, fragment spreads, that all, basically everything that could appear next to each other under the same object. And then what execute selection set does is it takes this selection set and passes it to a function called collect fields. Collect fields is going to recursively iterate through any inline fragments or fragment spreads and return a deduped list of fields back to execute selection set. And then for every field, execute selection set is going to invoke a function called execute field. That's what's going to call the field's resolver on the GraphQL server, get the result for the field, pass that to complete value. And then complete value is going to do some checks, ensure that the resolver return the correct type for the field. And if the field's a list type, it'll call complete value again for every list item. And if the field's an object type, it starts the whole process over by calling execute selection set on the selection set that's under the object. And then finally, you get the completed values for each executed field. Now I'm going to talk a little bit more about what changes we need to make to support defer and stream. Before we start off, there's a list called subsequent payloads that we use to keep track of our defer and stream payloads as they're encountered. Then back to execute selection set. Like before, we pass the selection set to collect fields. And again, collect fields is going to recursively iterate through any fragments. But now, if it sees a fragment with a defer directive, it's not going to recurse into that fragment selection set. Instead, it calls execute selection set on that fragment selection set and stores the execution inside of subsequent payloads. So what we've done is we've effectively forked execution at the point of this fragment, and we're now simultaneously executing our main set of fields and the deferred fields. So then collect fields is going to return the list of fields back to execute selection set, but this does not include any of the fields on the deferred fragment because those are being executed separately. And then execute selection set will invoke execute field for each field, resolve the fields, pass off the results to complete value. But complete value is now looking for the stream directive on any list fields there. So if it's completing a list field that does have a stream directive, it's going to proceed normally, completing each item in the list up until it reaches the initial count index. And now we're going to fork execution again and push the execution branch to subsequent payloads. The items that were completed before the initial count were reached get returned back to execute field, and each item after the initial count gets its own payload. Then the rest of the execution algorithm continues normally. But the forked execution paths can also encounter more defer or stream directives, which would lead to more executions being added into subsequent payloads. Then after all the execution of the initial data is complete, there's a new function called yield subsequent payloads that handles sending the results to the client. And so it'll always first send the initial payload. Then it checks which of the subsequent payloads are ready. And we also keep track of dependencies on these. For example, we make sure that streamed list items aren't sent out of order, or a deferred fragment isn't sent before the parent object is resolved. But other than that, the payloads aren't ordered and they'll be sent as soon as they're ready. So I'm going to talk a little bit more about our process for the proposal. It is a pretty large and complex proposal. So we created a dedicated repo to keep records documenting each decision. And basically every time a question or a discussion point or issue has come up, we created a GitHub top level discussion for it. I think there's almost 50 of them now. And it's organized in a pattern called architectural decision records, where you explain the background context around an issue, what decisions were made with the working group, the consequences of those decisions, and the current implementation status. And that's really useful for keeping track of what decisions were made, why they were made, how they affect the other decisions going forward. And it should be like a good resource for anyone that wants to get a background of why things are the way they are. And I'm going to highlight just a few interesting topics that have come up. As I showed earlier, each payload has a Boolean field, has next. And this should be used by clients to know if more payloads are expected. It started out as is final and was only needed on the final payload, but we found that it caused backwards compatibility issues. If a client was communicating with a server that didn't implement defer stream, it would never see is final in the initial payload, and it would get stuck waiting for more payloads. So we decided with the working group to standardize on the inverse form. We changed it to has next. And another case with this to consider is if you have a async data source like an async iterable, you may not know if there are going to be any additional list items until some time has passed after the final list item was sent. So for this use case, we allow a payload containing only has next false without any data or any other fields. And this can be sent when your data source eventually does indicate there are no more items. A while back, there was an experimental implementation of defer in Apollo server, and that implementation only supported defer on fields instead of fragments. And at first dibs, we tried to use it in our code, and we found that most use cases that we wanted to defer a group of multiple fields, and we wanted to block the whole UI from rendering until we had all the fields that we needed. And when you can only put defer in a field, that means that the client has to keep track of the loading state of each individual field and show a loading indicator until it gets all the fields that it cares about. Or you could just render the UI and just as each field comes in, start updating it, but that's a pretty bad user experience. Your UI will be repainting and reflowing many times as the data is loaded. So instead, by supporting defer and fragments, the client is basically telling the server to give me the results of all the fields in this fragment when that entire fragment is finished resolving. Now your client only needs to wait for this payload for the fragment and it could render its whole UI. And if you do want to defer only one field, you can wrap it inside of an inline fragment. That said, I don't think that having defer on fields is something that's ruled out entirely. We're not considering it anymore, but if there are use cases that come up that really need this, it could always be its own proposal in the future. Another topic that we spend a lot of time on in the working group meetings is the issue of non-null propagation. The the GraphQL spec requires nulls on non-null fields to bubble up to the next nullable fields. But you can't bubble up to a field that was already sent to the client. You can't go back in time and change what was sent. So the decision here was that defer and stream act as a null boundary. And I'll show a few examples of what that means. First, an example with defer. So in normal cases, the data field on the payload from a defer directive will always be an object. This is because we only allow defer on fragments. And we can use this to our advantage and let a null data field represent an error that should have bubbled upwards. So in this example, we have a deferred fragment on the person field. And the homeworld field is declared as non-null on the person type. But in this case, let's say the resolver either errors out or it returns null. And if this wasn't deferred, that null would have bubbled up and the person field would have been nulled out. But since we already sent that to the client before the homeworld was resolved, instead, we send the client the defer payload with the errors, and data on there is set to null. Now for an example with stream, the original proposal was to directly return a single streamed list item in that data field, but we decided to instead wrap the streamed list item in an array and call the field items instead of data. And this lets us support batching, but it also allows us to differentiate between a valid null result and a null that originates from an error, which should have bubbled up higher. So in this example, the heroes field is a list of non-nullable object types. And let's say the third result errors or resolves to null. What happens is the initial payload is sent normally. And then the second payload returns the second list item wrapped in an array. And in the third payload, the errors field is populated and the items is null, which communicates to the client that this null should have bubbled upwards. If the type of the list allowed null fields, it would have returned an array with a null value inside of it. So with both defer and stream payloads, whenever the data or the items field are set to null, clients know that this null should have bubbled up higher. And the spec doesn't require clients to handle this in any specific way. We just describe what the behavior is, but then clients can implement whatever makes sense for their use cases. Yeah, so that's all I have. I hope that gave you a good understanding of how defer and stream works. I have a link here to the discussion repo. I encourage you to look through it, start discussions if you have any questions, concerns, or feedback. There's also an experimental GraphQL playground, which has working examples of defer and stream. So yeah, thanks for having me.
Thank you, Rob, for this presentation. I think it's great to have a member of a GraphQL working group at GraphQL Wrocław giving an insight to what's going on currently, as this sounds as like very fresh feature. Is it supported already by some servers that you know, like probably Apollo server has some support for this?
Yeah, I know that Apollo server, if it's not out already, they are working on supporting defer. I know that there's the hotchocolate.net server has support for defer and stream. GraphQL.js has support in its latest alpha version. So other libraries that use that, if they don't have support already, it's something that could be added easily.
Yeah, and as a working group, do you like only work on the specification of the schema, or do you also provide like, because you showed a lot of examples of how it works internally, this is also part of like what you do like in the working group, like how it should work and how it should be implemented by other servers basically?
Yeah, the GraphQL spec has like very in-depth details of the algorithms that should be done for GraphQL execution. And so part of getting a change accepted is to have a PR that updates a spec to do whatever it needs, and it's a pretty big change to these algorithms to support defer and stream, as well as updating the reference implementation in GraphQL.js to implement what's described in the spec.
Yeah, that's great, because actually we have our own GraphQL server called Ariadne, which is Python one, and we should definitely look into this. Do we have any questions?
But what would happen if the spec mandate? What would happen when the client disconnect after first response?
The spec doesn't go into details of the transport specifically. So if there's a disconnection, that should be handled by, I guess, like the server and how it communicates with the client over HTTP.
Okay, then the server doesn't really specify how this should be implemented in HTTP protocol, or does it have a specific suggestions on how this should be implemented, on how these subsequent responses will be sent over HTTP?
Yeah, the GraphQL spec doesn't specify how it should be implemented over HTTP. It doesn't not for defer stream or for any kind of GraphQL request. It was always left open that you could implement GraphQL over any kind of transport, WebSockets, anything else. There's a new spec that's being worked on called GraphQL over HTTP, and that's a work in progress, I believe. But they're basically taking the what all the main servers already do and standardizing that. So you could advertise that you're a server that a GraphQL server that works over HTTP, and you'll be compatible with the other ones. And as part of that, we do have like a proposal of how defer and stream would fit into there. Does that answer your question?
Yeah, I think that's great. Thank you.
All right, any other questions? I forgot to add at the beginning that we have some swag for you. If you ask questions, you can get a t-shirt or socks. So. And now I see many questions.
Is there actually a technical restriction on why no defer on fields? Because I'm thinking in the case of like computed fields from a database, where that might be a really solid use case.
It does have implications of supporting it on fields has implications because your payload structure would change. If it's on a scalar field, you're no longer always returning an object type in the data property. And pretty much any use case of wanting to defer only a single field could be solved by wrapping that field in a small inline fragment. So we decided not to investigate it much more than that.
Cool, thanks.
Any other questions? I was also wondering if you could basically, or if it would make sense to, defer like most of your parts of your query. Like imagine that you have a e-commerce website, like you mentioned that you work on at First Dibs, and you have to load the product lists and the cart with some like checkout lines and stuff like that, and probably the user and maybe some blog posts that can be displayed at the bottom of the page. So would that make sense, or is it like some hidden cost to like basically defer all parts of the query?
Yeah, I think there's trade-offs. I think there's both design trade-offs where I don't think you want the layout shifting too much of too many asynchronous parts of the page coming in at different times. I think also technically, if it's not going to if the part that you're thinking about deferring loads pretty fast anyway, and it's not going to be slowing down the rest of your query, it's a little bit of extra work for the server to defer it.
Yeah. Do you use it at First Dibs on your like e-commerce websites already, or like test it with some queries?
Yeah, we are using it.
And like, what's the use case for that? Like, do you use some external services underneath that like needs to, you know, be deferred, or you have some heavy database, you know, queries or stuff like this?
Yeah, I think that one case where we're using it is there is some like promotional information that could be loaded when you're viewing an item that takes into account a lot of data about the user, their location, the item location, the price, and I think that's expensive. It's expensive for our backend to calculate, so so that's something that gets deferred.
Yeah, makes sense. Do we have any other questions? All right, I think that's it. Thank you, Rob, for the presentation. Very interesting stuff. It was great having you, so please, big applause for Rob.
Yeah, thanks a lot for having me.
Yeah, so I think that's it for the 11th edition of GraphQL Wrocław. So I wanted to show you one more thing, if we can have this slide. Yeah, so if you are here for the first time, you may want to check this out. It's a website with the description of some of the things that we do, some of the initiatives that we do at Mirumi and Sailor. Like, we have a lot of open source projects. You can scan this code or like take a picture and check it out and learn about our projects. So thanks for joining us today. We will host another edition in January. And I'll also invite you to submit talks. So if you work with GraphQL or you have some interesting use case to show, feel free to hit us, and you will be able to present something at GraphQL Wrocław. So once again, thanks for joining, thanks for supporting the GraphQL community, and see you in January. Thanks.